This is day 3 of Unit 5. We started today with a warm-up, so go ahead and pause the video, try it, and then play to check your answers. So I start by factoring this, looking at the two groups. I see that x plus 3 is in common, and I see squared and cubed, so I know squared is the greatest common factor. And then x minus 4. And I have to the first and squared, so the GCF is just to the first. So then after that, x plus 3 squared, and I need cubed, so I need an additional x plus 3. And then x minus 4 I already have to the first, so I don't need any more. So I'm ready for the plus sign and moving on to the second term. So x plus 3 squared I already have, and x minus 4 I need to be squared. So that ends my parentheses. So I have x plus 3, the quantity squared, x minus 4, and then x plus x is 2x, and positive 3 and negative 4 is negative 1. So that is my final answer for number 1. Number 2, really the easiest way is kind of just to probably guess and check this one. You can do a diamond in a generic rectangle if you'd like. I'm just going to try 3x and 2x though, because I know they multiply to 6x squared. And now I'm just going to think about factors of 15. So I know 5 and 3, I'm going to see if that's going to work. So I put the 5 here, 5 times 3, 15, and the 3 here. 3 times 2 is 6. 15 and 6 is not going to give me 19. So let me try 5 here. So 5 and 2 is 10. And 3 and 3 is 9. Yep, that's going to work because that's going to give me 9 and 10 is 19. And I want negative 19. So I'm going to put the 3 here and the 5 here. And in order to give me negative 19, I'm going to want them both to be negative. So 3 times 3 is 9, and 5 times 2 is 10, and they're both negatives, so that gives me negative 19. Now that's only going to give me negative 19x. It looks like I'm going to need y's as well, because I need the 5y times the 3y to give me 15y squared. So I know I need the y's as well. Plus now I have xy and xy, which will combine to xy. So 3x minus 5y and 2x minus 3y, those are the factors of 6x squared minus 19xy plus 15y squared. Okay, so today we did an activity with the graphing calculator, so you will need your graphing calculator for this. And the first thing that I'm going to do is to type this equation into the calculator. So let's go ahead and do that first. Okay, so I have the equation entered into my calculator here. I'm going to just do a zoom standard, which will take us to that negative 10 to 10, negative 10 to 10. So in that viewing window, I can see that I'm missing the bottom part of the graph. So I'm going to adjust my window to change the y minimum. I'm going to try, I don't know, make negative 60. And again, I don't know for sure. I'm just kind of guessing. And then I'm going to graph. It looks pretty good. We can see the entire graph now. I can see just by looking the x-intercepts. I can also sort of see what the y-intercept is, but I'm not sure what the value is. So a couple ways we can get those. So for the x-intercepts, remember, if I can't tell, which I can on this one, but if I can't, I can always do second, trace, and calculate the 0, and I can get the x-intercepts that way. I'm not going to bother to do that. I'm just reminding you in case you need to. And to get the y-intercepts, and also the x-intercepts, I can go to the table, so second graph. And oftentimes the y-intercept is visible right away. If you have your table starting at 0, I can see 0, negative 50 is the y-intercept. If not, and by the way, I can see 2, 0 is an x-intercept. I can use my arrow to scroll if it's close. If it's somewhat close, like ours is negative 5, 0, I can see that in the table. Now, let's say you're your table is currently set really far away from where the intercepts are, you're not going to want to scroll and keep scrolling. So if you ever need to adjust the starting place for your table, you'll do second and then window will allow you to change the table starting place. So if I want to start it at the y-intercept, I can type 0 in for x. And then if I go to the table, second graph, then it'll start it at 0 for x. So I now know that my x-intercepts are -5, 0, and 2, 0, and my y-intercept is 0, -50. So I'm going to use that information and come back here to my graph. So let me plot -5, 0, and 2, 0. And I'm just going to put a point down here and call that 0, -50, which is fine for a sketch. And then I'm just going to graph it the way it shows on the calculator. So I can see it looks like that, and it comes here and looks like that. This is -5, 0, and that's 2, 0, and that's my graph. So that's the first thing you'll do. You enter it in the calculator, adjust the window so you can see the full graph, and then graph that on your paper. Next thing you'll do is list the roots. Well, we can see that they are -5 and +2. Next, I'm supposed to put those roots on my number line here. And if you look in the directions, it says we're supposed to shade where the number on the number line where the value of the function, the outputs, is positive. Well, if I'm putting the roots on my number line, roots have an output of 0. Okay, which is neither positive nor negative. So when I put those roots on the number line, I'm going to use open points, which indicates that they're neither positive nor negative. So that's what I do first. Next, I'm going to look at the graph, and I'm going to start from the left side of the graph and move my way to the right. So I'm looking to the left, and I'm seeing that the graph from -5 to -infinity is below the x-axis. So because it's below the x-axis in that region, I'm not shading because there's not positive outputs. If this graph had been above the x-axis in that region, I would be shading. So then I'm going to check out the next region. The next region I'm going to check is from -5 to +2. So everything in between there. So the graph in between those two values is below the x-axis. So once again, below means negative output, meaning I'm not going to shade here between -5 and 2. Had the graph been above the x-axis, I would be shading between -5 and 2. The last region is from 2 on, and I see that the entire graph is above with a positive output above the x-axis. So at 2 on, I'm going to shade on my number line. You're going to do the next several graphs in a similar fashion. You'll put the open points on the roots on your number line, and then you'll just break it up into the pieces from the left side over to the first root to the second root. If there's a third root, the second to the third, and you'll just keep going until you get to the end of the graph, looking at piece by piece and determining if it's above the x-axis, you'll shade in that section. If it's not above the x-axis, you won't shade. So that's why I only have from 2 on shaded. So that takes care of part C. Next is the description, and it says for the description I'm supposed to list the degree. So looking at the equation, we talked about that the other day. I know that this is degree 3. Next, describe the graph. Describe what is happening at each 0. Well, at this 0, -5, and actually at the x-intercept, we have what's called bouncing happening. It's hitting the point, not going through the x-axis, not reaching the other side of the x-axis, but going back down where it came from. We call that a bounce. So that is a bounce at -5, 0. Okay, now we only consider it a bounce when it does not go through the axis. So when it never goes to the opposite side. So if this is my x-axis of a different graph, it could also come from above and hit and bounce. That would also be considered a bounce because it is not going through the x-axis. But if I have something like this, okay, these are all going straight through. Even though we have a curve here, that doesn't matter. It's what's happening at the actual x-axis. Those would be going through the x-axis. So none of those would count as bounces. So we only have one bounce here because there's only one point where it's not going through the x-axis. On the other hand, over here at 2, 0, it is going through. It's going from the below the x-axis to the opposite side above. So we call that a through. It's through at positive 2, 0. So that's what you'll list. Okay, so back to my examples here, this would be a through, 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 and through. All four of those are through the x-axis. This one here would be considered a bounce. Okay, so the next thing we're supposed to do is, that's what's happening at each 0. We're supposed to list the number of zeros. To do that, just go back up and count how many numbers you have listed there for the roots. So we would say 2 zeros. Okay, and the last thing we need to do is to list the end behavior. End behavior is what it sounds like. It is to talk about what's happening to the ends of the graph. In other words, what directions are the arrows pointing? Well, this is pointing down on the left, and the other arrow is pointing up on the right. So I would say that the end behavior of this graph is down, up. That's the end behavior for this graph. So that's what you want to list. So now each one of these, you're going to do the same, these same steps, follow these same steps for the next several graphs on pages 6 through 8. You'll first type the equation in your calculator, graph it, set the window so you can see it, graph it on paper, list the roots, make the number line based on shading where the positive outputs are or above the x-axis. In the description, you'll list the degree, where it's bouncing and where it's going through. Remember, you have to state what's happening at each one of those x-intercepts, how many zeros there are by counting up here, and lastly, what's the end behavior? What's happening? What direction are the arrows pointing on the ends? So could be down, up like this one, could be up, up if both ends were pointing up, could be down, down if both arrows are pointing down, could be up, down if the one on the left is pointing up and the one on the right is pointing down. So that's what you're going to do. You're going to list each one of those. Then for homework, in addition to finishing up those graphs and the descriptions, you will answer the questions that are on the top of page 9. Now, in order to answer those questions, you're going to have to look back through the lab, look back through all the different graphs, and you should be able to answer some of the questions, or those questions based on some of the patterns that you'll be noticing throughout the lab, throughout the graphs. Okay, so use your graphs to help you answer those questions on the top of page 9. Okay, and that's it for today. So please finish up pages 6 through 9, just the top of 9. You don't have to do the bottom part of page 9.